two topics. Okay. So we've got double angles and half angles. Okay. So the double angle formulas are on your unit circle sheets. Yes, they are numbers 21, 22, and 23. Really, we don't use the double angle formulas if I'm finding something like the cosine of 300 degrees. Okay? Because 300 is 2 times 150, right? So I could use that to find the cosine of 300 degrees, but we would just go to the 300 degrees and find the cosine that way. Okay? So it's not, the double angles aren't necessarily used to find actual cosines and sines and tangents. What they're used to find, and this actually works out well for us because this was probably going to be on your final on Wednesday, is we use them to solve equations. Okay? All right? So we use the double identities to solve equations. Okay? We don't necessarily use them to find the cosine of 225 degrees or something like that. Okay? All right? So these are on your unit circle sheet. Okay? So how I would go about this is I would say, well, the sine of 2x is equal to 2 times the sine of x times the cosine of x. And now I've got it where I'm in singleton angles all the way through. It's going to subtract sine of x from both sides. Then I'm going to factor out a sine of x. And once I'm done factoring and I can't factor any more, then I am going to now set my mini equations. So here I would say the sine of x is equal to 0. Okay, zero power or zero property, or zero product property is what I'm trying to say. And the 2 times the cosine of x minus 1 is equal to 0. And then I'm going to solve those two. First one's already solved. Whoa! That got a little funky. Two cosine of x is equal to 1. So the cosine of x is equal to 1/2. Now I look back on my unit circle and I say, where on my unit circle is the sine of x equal to 0? What you got? 0 and pi. Where is the sine, or excuse me, the cosine of x equal to 1/2? So I put those all together and I say 0 and pi over 3 and pi and 5 pi over 3 are my answers. Okay?
At the beginning, why couldn't you just divide it by sine of x?
Because I would have lost this. I would have lost this entire factor.
So how would you know, like, not
Never divide.
Never divide?
Never divide.
Okay.
Yep. Because you if it's a single solitary number, like if there was a 2 in front of all of them, then you can divide. But if it's a factor, meaning it's either x or some variable, then don't divide. Okay? Try that one. So what's the issue with this one? There's 3 different options to use, right? Okay? So let's think about this. So here I could go with, let me back up 2 slides here now. I could go with any of those 3 options, right? Okay? So you kind of got to plan your work to work your plan. You know what I mean? Okay? Right? I would like to get it down to 1 trig function, right? Instead of sines and cosines, it would be really nice to get it down to just either sines or just to cosines. Okay? So if I'm looking at this one, if I went with 2 cosine squared minus 1, right? I'm still going to have sines and cosines. Okay? So let's not do that one. If I go with 1 minus 2 sine squared, right? I'm still going to have sines and cosines. But if I go with here, if I make this one be cosine squared of x minus sine squared of x, what happens to my cosines? Because I've got a positive cosine squared on both sides, right? So those go away. So that leaves me with the sine of x equals negative sine squared of x. Now we can get everything onto one side. So I would say sine squared of x plus sine of x equals 0. Factor out a sine. So where is sine of x equal to 0? And where is sine of x plus 1 equal to 0? Let me bring this down a little bit more. What was that? So then we got sine of x equaling negative 1. All right? 0. Where is sine equal to 0? 0 and pi. Where is sine of x equal to negative 1? So we've got 0, pi, and 3 pi over 2.
What were the restrictions on it?
From 0 to 2 pi.
Did you have to include 2 pi, or is that not included in it?
not. Because 0 and 2 pi are the exact same thing. Okay? Alright, so that's double angle stuff. We use double angle formulas, numbers 21, 22, and 23, to solve equations. Okay? Now let's jump into half angle identities. These are not on your unit circle sheets. Okay? So I'm going to give you some time right now to write them down.
So we're not provided with them like on the test?
Correct. But you have a note sheet on your test, okay, that you can put them on. Okay? Meaning, I wouldn't put them on your unit, you can put them on your unit circle sheet for now, but at some point in time, you should transfer them to the note sheet that we gave back to you for the final, that you started first semester. Okay? Anybody need more time writing those down? Okay. All right. So, I want us to find the exact value of the cosine of 105 degrees. Okay? So the formula for the half angle of cosine would be, so the cosine of u divided by 2 is going to equal plus or minus the square root of 1 plus the cosine of u divided by 2. Right? Okay? Now, with half angles, you're not going to get two answers. That plus or minus sign out in front here, that's going to either become just positive or just negative, depending upon what quadrant your angle is in. Okay? Remember, in quadrant number 1, all of them are positive, right? Sine, cosine, and tangent are all positive in quadrant number 1. Okay? In quadrant 2, which ones are positive? Quadrant 2, sine is just positive. Quadrant 3, tangent is just positive. Quadrant 4, cosine is just positive. Okay? Alright? So which quadrant is 105 degrees in? Quadrant 2. So is cosine positive in quadrant 2? No. Sine's the only one that's positive in quadrant 2. Okay? So this, our answer here, is going to be negative. So I'm going to start with the negative sign. Okay? Then I'm going to say to myself, self, 105 is 210 divided by 2. Right? So my angle that I'm going to use in my formula is 210 degrees. And now that's on my unit circle. Okay? So what is the cosine of 210 degrees? What did you say? Negative square root 3 over 2? Now, that's kind of a funky looking fraction inside of a radical. We got a radical inside of a radical and a fraction in a fraction and a fraction. You know what I mean? Okay? So we got to do some math stuff to clean that up a little bit. Okay? So really what I'm doing is I'm looking here just at that inside fraction, right? If I multiply both top and bottom by 2, legally, can I do that? As long as I do it to both, I can do it, right? Okay? Because really I'm multiplying by 1. If I just multiplied the top by 2, would that be legal? No, because then I would be changing that fraction. Okay? So if I multiply everything by 2, then my top here is going to be 2 minus the square root of 3. Right? 2 minus the square root of 3. What's the bottom? 4. So the cosine, the exact value of the cosine of 105 degrees is going to be equal to negative square root of 2 minus the square root of 3 all over 4, right? Which I could, go ahead.
Can you not divide those by 2 because you're subtracting the square root of 3?
Correct. It would have to come out of the square root of 3 also. Okay? Which, if I went a step further, now I could say that this is negative square root of 2 minus the square root of 3 all over the square root of 4. Right? Radical of a fraction, take the radical of the top and radical of the bottom. Which then that could be that. Radicals inside of radicals. Good times. Okay? Questions on that? Find me the sine of 75 degrees. And 75 is 150 divided by 2. Okay? So this is going to be, so the sine of 75 degrees, since 75 degrees is in quadrant number 1, everything's positive, so that's going to be positive. And then it's going to be 1 minus the cosine of 150 degrees all over 2. So that's going to be 1 minus cosine at 150 degrees is negative root 3 over 2. And then over 2. Again, multiply both top and bottom inside the fraction by 2. gets me that. Take the square root of the top and the square root of the bottom, and we get that the sine of 75 degrees is equal to the square root of 2 plus the square root of 3 all over 2. Okay? Good? Again, half angle formulas definitely want to go on your note sheet. Wink, wink, nudge, nudge. There is a final question with the half angles on there, so you definitely want to get those on there. Double angle formulas already on your unit circle sheets. Okay, so we're good to go with that. Questions for me? We'll make sure we got the answers posted by the end of the day on It's Learning for the review packet. But then our plan for Monday and Tuesday is to straight up review and answer questions and get all that stuff done. Okay? Thanks for playing along.